Hey guys, I want to go ahead and talk about solving some of these exponential equations. They can be a little bit tricky, but if you see the little trick and patterns, it's kind of easy. I'm going to start with the first one. It's kind of easy. If you notice, if you know your exponents, this guy right here is 16 is actually equal to 4 squared. And over here, now I have 4 to the power of x plus 3. Now you see how the bases are the same? Because of that, that means we can set our exponents equal to each other. Therefore, the 4's drop off, and we have x plus 3 is equal to 2. When we solve it, x is equal to, I believe, -1. And there it is. Okay. Now, number 2, you see it's a little bit different. We're going to have to use our logs for that. Okay. So when you see this, think about using logs. Now, this guy right here, okay, watch what I'm going to do. I'm going to split this guy up right here. He's going to become 4 to the power of x times 4 to the second power, or 4 squared. Now I'm just using the exponent properties, power rule, okay? And 4 squared becomes 16. So we have 4 to the x times 16 equals 17. Or actually I can write it 16 times 4 to the x equals 17. Divide by 16 on both sides. That becomes a 1. I'm going to bring it up here. Okay, that becomes 4 to the power of x is equal to 17 divided by 16. 17 divided by 16 is 1.0625. Now, how do I get this x down? Well, you're going to have to take the log on both sides. Alright, so you're going to take the log on both sides. Log of 1.0625. Now, because of that, you can use the power property of logs. This guy goes down. So we have x log of 4 equals log 1.0625. Divide both sides by log of 4. Okay. And that should give you your answer. So all I have to do is divide these two and get my answer. So let me get my log. That becomes log of 1.0625 divided by the log of 4, and that's going to give me 0.0437. Alright guys, so it's very important to try to isolate this 4 to the x and the exponent, and then you're going to use the logs to bring it down. Now remember, just be careful, this is the base is not 4, okay? The base here is just a 10, a normal log base. So let's do number 3. Same thing. So you start solving it like an equation, a normal equation. So you're going to add 300 to both sides. So you're going to get 10 times 2.4 to the power of x. When you add to both sides, you get 800. When you divide by 10, you're going to be left with 2.4 to the x, and you're going to get 80. Same thing, we have an x left on the exponent. We're going to take the log on both sides. So we're going to have log of 2.4 to the power of x equals log of 80. Because of that, now I can bring down my x. So I'm left with x log of 2.4 equals log of 80. Now, does this parentheses matter? No, it doesn't. I just like to put it there because we're working with a decimal. So we just make sure that we don't misunderstand the 2 and the 4, they're together. And then I just go ahead and divide, and I'm running out of room, but let me put it up here. So x is going to equal to log of 80 divided by log of 2.4. And same thing, get my calculator. Log of 80 is divided by log of 2.4. And actually this comes out to be, let me do it down here, x is equal to about 5 even. Alright. Number 4. This one is a little bit tricky, or it seems like it. But you see how I have the 5 here in the front? It's a multiplier. So I'm going to go ahead and divide both sides by 5. And when I do that, so divide this whole thing by 5, divide by 5, I'm left with log base 4 of x plus 3 equals 15 divided by 5 is 3. Now be careful, the x plus 3, you cannot do anything with that just yet. You have to leave it inside because it's part of the log. A lot of students like to subtract 3 on both sides, but you can't do that. Now right here, this is a little bit tricky, but notice anytime you have this form, try to change it into an exponential. A lot of times you'll see that that's going to help you out a lot. So 4 to the third power is equal to x plus 3. See, so now I'm left with just numbers. The log is gone, and that makes it a lot easier. 4 cubed is, I believe, 64 equals x plus 3. And then when you solve it, x is equal to 61. Okay? So notice what I did. I divided, simplified, and then I changed it from a log to an exponential. And the last one, okay, guys, this guy right here, same thing. Divide by 12, but unfortunately, this guy doesn't seem like it's going to come out evenly because 18 divided by 12 is not. I'll just do it as a decimal. 18 divided by 12 is 1.5. But we have a decimal as an exponent, so how do we do that? Well, there's a nice little algebraic element that you can do is you can multiply by the reciprocal. So just remember, just like 1/3, multiplying it by 3, that's going to give you a 1. Same thing over here. If we have 2.1, if we multiply by 1 over 2.1, okay, I'm going to get a 1. So that's what I'm going to do here. So x plus 3 to the 2.1 power, I'm going to multiply it. So this is 2.1. I'm going to multiply by 1 over 2.1. You see that? And these guys are going to simplify into a 1. I can put a 1 underneath there. And then whatever you do on the left, you do on the right. So now I get 1.5 to the power of 1 over 2.1. And of course, you're going to need your calculator for that. So we're going to be left with x plus 3. Let me see if I can do this. To the power of 1 divided by 2.1. And I get 1.212. So now from here, I go ahead and subtract 3 on both sides. X value is equal to negative 1.787. Alright guys, so hopefully those help out, and let me know. I'll keep making some more videos.